called ride index, and ride index is a parameter which indicates as to what is the riding comfort. It's a number. So say for example, the ICF coach ride index is 3.25, whereas the ride index of LHB is 2.75, and this number is translated into hours of comfort. So you will find that if you travel in an ICF coach, you find that you get discomfort after 6 to 8 hours of travel. Parallelly, if you travel in the same class of an LHB coach, the discomfort duration would be longer. Say you would start feeling discomfort in 10 to 11 hours or 12 hours. You travel in Shinkansen, the ride index is 1, so you will feel a discomfort after 20 hours of travel. So it also correlates that when the ride index is better, the suspension in the coach has to be better. And when the suspension in the coach is better, the cost of the coach manufacturer goes up. So if an ICF coach is costing you around 80 lakhs, the LHB coach of a similar variant would be costing 1.5 times the cost of the ICF coach. So LHB came in with a promise of a better ride index. Then the components in the ICF coach undergear was having a larger number of components, so it required more electrical maintenance involved mechanical maintenance. So these were some promises as to why the LHB coach was introduced. Some more advantages: because it is longer in length as compared to ICF, you have a higher carrying capacity, weight is lesser, corrosion is lesser, it requires lesser maintenance. In case of ICF, we used to lift the coach after 9 months, whereas in case of LHB, we lift the first lift of the coach is after 18 months. LHB coaches have been designed aesthetically better. We have used large amount of FRP. If you enter an LHB coach, you will not find any visible screws on the panel bodies. So it gives you a better passenger experience when a person is traveling in an LHB coach. As a better ride index, it is safer. Now, fire retardant material and furnishings can be used in the ICF coach also, but LHB, as per design, we started using large amount of fire retardant material initially itself. Plus, it is more safer because it is provided with a center buffer coupler vis-a-vis a screw coupling which is there in the ICF coach. So, screw coupling had a tendency to part, whereas the center buffer coupler can take higher impact loads. So the tendency of parting is not there. The second point is that the body and the bogie joint is much better in the LHB. So if in case of derailment or an accident, the circumstance will not occur where the bogie will separate from the LHB coach body. Whereas in ICF, the joint was only on a center pivot pin, and the center pivot pin would shear off, and hence the amount of accident havoc which used to happen in ICF was much more higher as compared to that in LHB. Because it is a longer coach, it is a bigger coach, you have more space for pantry, and this is a reading light in chair car, and ergonomically designed chairs is only cosmetic, which can be done in the ICF coach also. Now, at par with the ICF, these are the codes which are there in LHB. So if you take the AC 3-tier sleeping car coach, it is LWACCN, whereas if it would have been LHB, if it would have been ICF, we would have written WGACCN. So L indicates it's an LHB coach, W is a vestibule, AC it is air conditioned, CN is a code for the 3-tier sleeping car. So the coding also is pattern between ICF and LHB is more or less similar. Now this is what the Fiat bogie or the LHB bogie looks like. It's a very simple design. So there are two Y frames, and so this is called a Y frame. So there are two Y frames, and the two Y frames are connected through a cross member. The coach body comes and sits here. This is the secondary spring. This is the primary spring, which is guided with a control arm. And the weight transmission happens because the weight comes on this cross member, comes to the secondary spring, comes to the Y frame. From the Y frame comes to the axle arm. From the axle arm goes to the wheel, and from the wheel it goes to the ground. So you see the LHB bogie is a very simple bogie, and you should also see one difference more which is there between LHB and ICF is that the LHB is provided with something called disc brakes. The ICF is provided with clasped brakes. Now, when the brake blocks are placed here, then it is called a clasped brake, whereas the LHB is provided with a disc brake. Also, we have started providing air springs in the LHB coach. Now, it's a bellow of air which is used. And when you use a bellow of the air, the suspension, this is the bellow of the air, this is called the air spring. So So this bellow gives you better rideability because it is easier to control the amount of air which can be pumped into these bellows. So there's a bellow on this side, there would be a bellow on the opposite side. So air bellows, we have started providing air bellows in the secondary suspension, and this is also essential if you have to take the speed higher to 200 kmph. So this is the comparison of the periodicity of the maintenance schedules. At par with ICF, ICF was A, B, and IOH, and then POH. Here it is D1, D2, D3. What is important to see here is that whereas we were lifting the ICF coach after 9 months in LHB, the first time we lift the coaches when it comes to the shop at a period of 18 months. So the maintenance interval has increased in LHB vis-a-vis ICF. Now, this is what is the difference is in the braking system. The ICF is provided with class brake. The Fiat is provided with the axle mounted disc brake. Now, if you see this photograph, in this photograph on the left hand side is the ICF bogie, and the ICF bogie has a clasp brake. So these are the brake blocks which are clasping the wheel from both the ends. And initially these brake blocks were of cast iron. Subsequently we changed them to composites. And when a braking operation happens in the trains, you can smell that burning smell. Now the stipulation is also that we should remove composite also, because while burning it is releasing carcinogenic components. But yes, that process is on. So this is what is the clasp brake. And now what used to happen was, when this brake block rubs against the wheel, a large amount of heat is generated. When that heat is generated, that heat gets retained in this wheel. And because of this high heat, there are tendencies of the wheel to get damaged. So there is a phenomenon called wheel shelling or skids on the wheel. So the wheel starts getting damaged. That is why in case of LHB, what has been done is that the brakes have been shifted to this disc. So there is a disc which has been provided. These are the caliper brakes, and whenever the braking operation happens because of these pneumatic cylinders, these calipers rub against this disc and give the braking action. Now this disc also acts as a big heat sink. There are fins which are provided, so the heat dissipation is better. What we have done is we have tried to save this wheel by shifting the brake blocks from the clasp design to the disc design. So this is called the disc brake, which is there in LHB. Now this is what a center buffer coupler looks like, and the LHB has been provided with a center buffer coupler. So the process is that there are no buffers in the ICF coach. If there would have been an ICF coach, there would have been a buffer here. There would have been a buffer here, which used to take the buffing forces, and there used to be a screw coupling here, which takes the tractive forces. Whereas in case of LHB, there is only one center buffer coupler. This is something, a design which is similar to what is there in the freight trains. And in this center buffer coupler, behind the center buffer coupler, there is a rubber pad. Now this rubber pad takes both forces while it is doing traction or it is braking. And the center buffer coupler is considered to be much more safer as compared to the screw coupling. Now this portion is called the knuckle. So what happens at the time of coupling, two knuckles, so one coach from here and another coach from here, or a loco from here and a coach from here, these knuckles get connected to each other. There's a principle similar to what has been followed in the freight trains. So some benefits as to why CBC is better than screw coupling: has higher strength. So if it has higher strength, haulage of longer trains is possible. It has an anti-climbing feature. On top of the center buffer coupler, we provide a plate so that it restricts the movement of the center buffer coupler in the vertical direction and does not permit the coach to separate in the vertical direction. Shunting at higher speeds is possible. What happens when you are connecting an ICF coach with the locomotive? The pointsman or the person has to enter between the locomotive and the coach to connect that hook. So a person will enter between the locomotive and the coach. The coach will come slowly closer to the locomotive, and a person will enter between that space and provide a coupling. Whereas in case of a center buffer coupler, the coupler can be opened from outside of the coach only, and no person needs to enter between the locomotive and the coach to couple the train. So that is why it becomes safer for the person who is doing the coupling portion. It has CBC has lesser maintenance. and has higher energy absorption because of the rubber pad which is provided behind the center buffer coupler. Now, there are two programs which were launched by Indian Railways. They were called Swarn and Utkrist. So, program Swarn was launched around 3-4 years back, in which we said that we'll upgrade the facilities of all our Rajdhanis and Shatabdis. So, we'll provide better interiors, we'll provide better linen, we'll provide better cleaning facilities, we'll provide water filters, we'll provide bottle warmers, we'll provide CCTV cameras. So, these are some of the facilities which were provided under Swarn program, and all Rajdhanis and Shatabdis were covered. Then a thinking came that why should we restrict ourselves only to Rajdhanis and Shatabdis, and we should extend this facility to a large number of mail and express trains also, which are working over the country. So a project called Project Utkrist has been launched, and you will see those yellow colored trains. The color code now which has been adopted for Utkrist is yellow colored trains, and these yellow colored trains have been given an input of 60 lakh rupees per rake, where we are trying to upgrade the interior facilities of these trains, and this is called Project Utkrist. This is a new coach, a smart coach, which has been developed last year. This coach is an effort to move towards condition-based monitoring system. So what has been done is that a microprocessor has been provided inside the coach body, and a sensor has been fitted on the axle. So we have fitted a sensor on the axle, and this sensor is primarily monitoring the performance of the bearing on a real-time basis. You see, it's a component. So this is a sensor which has been provided in the bearing, on the top of the bearing. And this sensor is continuously monitoring the health of the bearing and relaying the information through that microprocessor to a central control. So what happens, the central control gets a pre-alert, or they can plan in advance, knowing when the bearing is going to fail, and we can avoid a midline section failure. Besides this purpose, the microprocessor is also talking to the various other systems which are available in that code. So it may be the CCTV surveillance system, it may be the AC system, it may be an intelligent thermostat which is provided inside. The microprocessor also provides the GPS based signals, it provides infotainment, it is talking to the destination boards. So this technology has been brought into this coach, and it has been named as the smart coach. 100 coaches of this design are being manufactured by MCF in this year, and if the experiment is found successful, then this would be the design of the coaches which would be adopted for future. Now, this slide I've only shown you to explain to you the concept that we paint the exteriors of the coaches for prevention of corrosion. So what we have started doing is that in place of painting the exteriors of the coaches, we provide something called vinyl wrappings. So these are vinyl wrappings, and it's a wrap which is provided right around the coach body. The two benefits which are provided with the vinyl wrap is, first of all, it is preventing corrosion. Secondly, this place can be used for advertisement purpose. So you will find that we have leased out these places for advertisement purpose. In this case, the vinyl wrap has been added, indicating as to what the railways has been doing for the Kumbh Mela. So it is basically an effort for eyeball coverage that railways has also done, contributed a large amount of work towards the Kumbh Mela. Now, this is a new project which has been launched, which is called Quick Watering. We had discussed that we want to increase the average speeds of our trains, and one of the effort there is that we have to reduce the the platform occupation time. Now, when a train comes on a major station, one of the major activities is watering of the train also, and in the present conventional system, it takes around 15 to 20 minutes to water a complete train. So this project has been launched, which is called Quick Watering. In this, what we are trying to do is we have improved the pipelines, the water pipelines which are available at the stations, increased the horsepower capability of the pumps which are provided there. And earlier, what used to happen was a valveman used to go and open all the valves individually. So we have automated the valve lines here now. So eliminated the need of the valveman, brought in PLC control. So at one place only we can control the opening or closing of all the valves across the pipeline. So we can control the flow of the water and also the pressure of the water which is being used for filling up of the coach bodies. Now, laundry requirement is immense in Indian Railways. We provide linen in the coaches, and as of now, we have requirement is around 423 tons per day, and the installed capacity is around 244 or 245 tons. Railways is planning to set up more laundries. There are large number of projects which have been sanctioned, and the principle to be adopted is on boots. That is build, operate, own, transfer. This is what a boot laundry looks like. So this is an example of a boot laundry. These are the interiors of the boot laundry. So you will see that large number of washers are there. And this is the activity where the linen has come from the coaches, and people are segregating and putting in soiled sheets at one place, or comparatively cleaner sheets at other place. In this boot laundry, what is something interesting to see is this machine is called a calendaring machine. Now, what happens once the linen comes out from the washer, the people will put these wet bed sheets inside this calendaring machine, and when the bed sheet goes across this calendaring machine, it steam dries. It is dried, so it is pressed. It is folded and it drops as a folded kit here, and the same is packed and then supplied to the people. The approximate weight of each bed sheet is around 400 grams, and the linen which you get, the package is around 1 kg, and this helps you to calculate the number of linen which would be required for a train. So say for example, if it is one AC3 tier coach with 72 berths, so you would need 72 sets of linen plus another 10-15% as spare. And if it is up and down, so one you may find that one AC coach attendant for one AC3 tier is carrying to the tune of say 200 sets of linen, and assume it with 20 coaches. So there are the work is involved as collection, distribution, washing of 4,000 linen sets per train, and assuming there are 15 trains which are dispatching. So this work is also pretty huge. Now, we had discussed that we are washing our coaches on the washing lines, and we do exterior cleaning, consume large amount of water. Water is money because we are purchasing it from the municipality. Besides consumption of water, the manual activity is very time consuming also. So we have started fitting these automatic coach washing plants. This is what the automatic coach washing plant looks like. So there are huge rollers or huge brushes, and the train passes right across this automatic coach washing plant, and the exterior gets cleaned till at the time when it is getting placed for maintenance. So all the major coaching depots are now being started providing with automatic coach washing plants. We have also gone a step ahead where we are clubbing water recycling plants along with the coach washing plants, so that the water consumption reduces even further. Now, you all have traveled in coaches, and you find that we have started using something called bio toilets. Earlier, we used to have open defecation, so there used to be a chute which used to go down, which was open to the ground. And when you used to use the toilets and all, the fecal matter used to drop onto the rails. Now, NGT passed a structures on the railway saying that you have to stop open defecation because it is a pollutant, and secondly, the fecal matter was corrosive in nature. It used to rust the rails. So these were two reasons as to why Indian Railways decided that we have to stop open defecation. And in the 1990s, towards the end of 1990s, we developed a design of a bio toilet with the help of DRDO. Now, what exactly is a bio toilet? In the coaches, you will find that there are huge tanks which are located at the end of the toilets underneath. So, in those tanks, live bacteria is available, live anaerobic bacteria is available. And when a passenger uses the toilet, the fecal matter drops into the biodigester tank. The anaerobic bacteria acts on the fecal matter, breaks it into methane and water, and the same is exited to the atmosphere. But when the biotoilets got introduced, a problem of stink came in. So a large number of complaints are there for bad odor, which is happening in the biotoilets. When the conventional toilets were there, the open chute also used to also helped in permitting natural air to come from the bottom inside the coach. Whereas when we closed the open chute, the ingress of fresh air inside the coach got drastically reduced. So some steps have been taken. You will find that on the toilet doors, louvers are provided. Inside the toilet, the windows are of hopper design. That means the top portion can be opened. The exhaust fan capability, which has been provided in the toilet, has been augmented. Some more steps have been taken. Eventually, has been added to pump in fresh air from outside inside the toilet. The cleaning agents which have been used in the toilets have been improved. Sometimes we are using odor masking by providing auto janitors also. So these are some of the steps which have been taken to tackle the problem of bad odor in the bio toilets. Now, we have also gone a step ahead. We have started introducing something called bio vacuum toilets. Now, when you travel on planes or you go to the malls and you use the flush, there's a gurgling sound. So that gurgling sound is basically vacuum suction. So even in the railways, the new coaches are coming up with something called biovac toilets, where a ejector or a suction device has been provided inside the bio toilet system. So when the fecal matter drops into the bio toilet, it is with a vacuum assist suction that the fecal matter is sucked in, and the fecal matter drops into the biodigested tank. And again, it is acted by bacteria and broken into methane and water. Now, the benefit of vacuum toilet is the first thing is that the water consumption has drastically reduced. The amount of water which is required for vacuum flush has reduced. So when water consumption reduces, the watering requirement reduces. Again, you can water a train faster on a station. And secondly, the vacuum suction, because it is vacuum assisted suction, the tendency of the fecal matter to stick on the pan walls has considerably reduced. So it will also contribute in controlling the bad odor which may happen in the toilets. Now, this is what a bio toilet conceptual design looks like. So there is a pan at the top. So this is the pan and this is the biodigester tank, which is having 6 chambers, and live bacteria is pumped into these chambers. So whenever the coach visits the coaching depot would pump in live bacteria, and the bacteria has conditions that it can survive in the conditions of Indian railways, and the bacteria acts on the fecal matter. Now, this slide tells us what are the various power supply systems on coaches. I told you that inside the coaches, there is a light, there is fan, and there is AC which is provided. The load of the light, fan, and AC is called total load. Now, in case of the ICF coach design, the ICF coach design used to be called as self-generating coaches. So, if you remember the code WGACCN, G indicated it is a self-generating coach. So underneath an ICF coach, a alternator is provided. The alternator is driven with help of V belts through a pulley which is there on the axle of the ICF bogie. So what happens when the train is in motion? The alternator will work and will produce electricity, and that electricity goes inside the coach bodies to take care of the total load. Whereas when the LHB coach came in or the design of the Fiat bogie came in, there is no provision of an alternator. So if you have a rake which is provided with LHB bogies, you need an external source of supply to take care of the hotel load. There are two methods by which it can be done. First is called end-on generation. Now, in case of end-on generation, you have two power cars at the ends of the coaches. When you travel in Rajdanis, you will find there are two power cars at the end of the coaches. These power cars are provided with DG sets. So there are DG sets. These DG sets, when they work, they will provide current, and with the help of couplers across the length of the train, we provide electricity supply for the hotel load portion of the coaches. Now, the problem with end-on generation is that if you are using two power cars in a rake of say 22 coaches, you have lost earning capacity of two coaches. Because if there were no power cars and there was another method of electrical supply, you could have added two more coaches. Secondly, this when a DG set is working, the efficiency factors are lower. The electricity which is getting generated in the DG set and getting transmitted is more expensive. It is causing a lot of pollution in the sense of noise and emissions. So the world has moved to something called head-on generation. Head-on generation is the principle where the power supply or the hotel load of the coaches is taken care by power supply from the locomotive itself. So in case of head-on generation, what will happen? The panto, when it is drawing power from the catenary, it is giving that power for traction purposes to the locomotive also, and that power gets transmitted to the coaches also to take care of the hotel load. So this is the concept which is there world over, and it is called head-on generation, considered to be the most efficient, and this eliminates the problem of the pollutants. This also permits you to add more coaches in place of the power cars. So even the Indian Railways has started adopting the concept of head-on generation, and all the LHV coaches which are now coming out are capable both for EOG and HOG. So that means you can straight away convert an LHV coach into a HOG coach also. So we have moved from SG to HOG. SG was the ICF family, EOG, HOG is the LHV family, and even in LHV, HOG is what is the latest concept. So these are all slides which basically tell you what are the some more merits and demerits. This is the alternator. So this is the self-generating feature which is there in the ICF coaches. So this is an alternator which is hung from the coach body, and this is the axle. On the axle there is a pulley, and from the pulley you will find that these V belts are there which are giving drive to the alternator. You would also find sometimes when the train comes on the platform and your AC cooling has gone down, the coach attendant will say, look, wait for some time. As the coach picks up some speed, the AC would start working better. So basically what he's trying to do is that when the coach starts moving, this alternator will start producing electricity because it is going to get some drive from the axles. So now we talk about what are train sets. Basically, India is the one of the few countries which runs such long trains. So we have a conventional train. A conventional train has a locomotive at the head of the train. We have around 20-24 coaches behind the trains. Whereas a train set is formed by a consist. So there can be a consist of 4 coaches, and again that same design is replicated. So for example, your EMU, DEMU or train 18 is a train set. So there will be one coach, one coach, one coach, one coach. This will form one consist. There will be one more consist of one coach, one coach, one coach, one coach, and they'll get coupled together. So this is a train set of 8 coaches. You may attach one more combination, it becomes a train set of 12 coaches. Now, train sets have some inherent benefits as compared to the conventional train. One of the benefit is that in a conventional train, the power is concentrated only at the head of the train. So what will happen? The impact load on the coupler, which is coming, say, at the 24th coach would be very heavy as compared to what is there on the first coach. In case of train sets, the power is distributed across the length of the train. So we would have some power here, some power here, and some power here. The benefit is that the coupler loads which are now coming on the coaches gets uniformly distributed across the length of the train. So it makes the train safer in the sense that it will not have a tendency to part. Second benefit is because we have given multiple power units now, even if one power unit fails, there would be no midline section failure because the train can be cleared by the balanced power units. The third benefit is that the train sets generally have cabs at both ends. So in a conventional train, if a conventional train comes to the platform and if you need to change the direction, loco reversal is involved. The loco would go from the front to the back. It's a time-consuming exercise and leads to higher platform occupation. Whereas a train set conventionally has cabs at both ends, so it has faster entry and faster exit. Conventionally, also the train sets are slightly more overpowered as compared to the conventional trains. So what happens? These train sets have faster acceleration and faster deceleration potential. Under Mission Raftar, the plan is that especially on the Golden Quadrilateral, we want to remove all our slow passenger moving train with train sets. So these are some of the benefits of what the train sets are. Like I already told you that it is distributed power, no reversal requirement, faster acceleration, deceleration potential, better utilization of onboard and platform space. What happens in train sets, because we have distributed the power, we try to accommodate all the components of transmission or powering underneath the coach body. So above the coach body, the space is available for passenger use and has lower coupler forces and uniform weight distribution. Depending upon the requirement of power which is in the coaches, you can decide whether you want to power only the exterior axles or you want to power larger number of axles. So say for example, Vande Bharat, 50% of the axles are powered. Now, a new directorate called Environment and Housekeeping Management Directorate was set up in around 2015, 2016 in the Railway Board. This activity got prominence also because of the Swachh Bharat plan which was launched, and a large number of activities which were earlier being done individually by different departments were brought under one department. So Environment and Housekeeping Management Directorate is there in Railway Board now. It primarily looks after the on-board housekeeping services in the coaches, the washing and cleaning of the coaches, the washing and cleaning of the stations, which was earlier done by commercial or by the medical departments. All these people have been brought under the purview of ENHM Directorate. Also, India is a signatory to COP, and Indian Railways, though it is not a big polluter, but Indian Railway has also promised some INDCs. Why Indian Railways was selected for promise of INDCs was because if any action is taken in Indian Railways, the impact is far reaching. The information travels in the country faster. So this directorate also this directorate on behalf of Indian Railways would promise those INDCs, get it followed up. It'll correspond with the NGT. Say if some environment related works have to be introduced, like water recycling plants, the construction of rainwater harvesting pits, introduction of a new water policy for Indian Railways is done by this directorate. So this directorate issues something called an Environment Sustainability Annual Report. If you go on to the website, Indian Railways website, and Google out, you can see the latest annual report. These are the some promises of NDCs which we have given, that we'll reduce our emission intensity by 33% in 29-30 over base year of 4 and 5, increase the modal share in freight transport, set up DFC, introduce more renewable energy, start blending biofuels, go in for waste management and all. Also, this directorate launched this certification system for all the facilities of Indian Railways. As a first step, the stations are getting covered under this rating system. There is a green rating system which has been developed and introduced in association with CII, Confederation of Indian Industries, Sorabji Center, Hyderabad. So this is something the rating system which has been developed has got some pointers, and these people will come and inspect a facility against those pointers. So say for example, the rating system says that you should have a mechanism of energy audits, you should have a mechanism of water audits, you should have rainwater harvesting, you should use LED lights, you should use solar panels. So they'll come, they'll inspect, and they will rate the station or a premise for such rating. So, for example, they'll go to Secunderabad station and find that what all facilities are available. And they have rated Secunderabad station as platinum. So there is silver, gold, platinum. This is supposed to be an annual audit, and as and when you are introducing facilities, your rating can go up. So it's just a snapshot to indicate what is green certification. There is another green certification method which is called Griha, which has been launched by Theory, but Indian Railways went in with CII and has adopted this certification system. Now, these are also driven by cases in the NGT, and this is one activist who keeps on doing cases in NGT on environment related issues in Indian Railways. Now, this is the latest orders from the NGT, where they have directed Indian Railways to develop eco smart stations. So what has been done is that Indian Railways, to start with, has said that out of 720 A1 class stations, we'll pick up 5% of our stations, which comes out to say around 37, and we'll develop them into eco smart stations. Now, the condition in the eco smart stations is that first of all, a very well defined structure has been created at the station level. So a station master plus a team of 2 people would be there. Then at the division level, ADRM would be heading a committee. At the zonal level, the AGM would be heading a committee, and they would be overseeing the work of the Eco Smart station as to what all activities they are doing. Second stricture is that on the Eco Smart stations have to develop a website. On the website, they have to disseminate information as to what are the water audits they are doing, what are the energy audits they are doing, what are the water recycling and water conservation efforts they are doing. On these eco smart stations, the polluter pay principle has to be imposed. That means if you pollute at the station premises, we'll impose a penalty on. So these are some of the conditions which have been laid down in development of these eco smart stations, and slowly you will find all stations get converted into eco smart stations. Now, this is a concept which is called rolling stock 2. What has been done is we're basically trying to move the inspection from man-based to machine-based so as to eliminate errors. You would see that we do inspections at large places. So, for example, in place of rolling in, rolling out, doing the inspection with the help of a person sitting on both sides, we have provided high-speed cameras. In place of for checking the condition of the bearings, you provide something called acoustic bearing detectors or temperature detectors to check the condition of these bearings. So what was happening was earlier we were having individual efforts which were going on. So now a program has been launched for Indian Railways where we are trying to club them all under one single umbrella, and these individual efforts are getting clubbed together. So like this is a new drone which has been developed named as Ustad. Undergear surveillance through artificial intelligence assisted drone. It's basically a device which travels inside the pit and can see the undergear condition of the coaches. So when the coach comes onto the pit line, we can use this drone for maintenance activity. This has been sanctioned in the Indian Railways for procurement. This is a new concept called MBIS, Machine Vision Based Inspection System, where a set of cameras is being placed, and when the coach or when the freight train or the coaching train passes across this, this will tell the coaching depot or the freight yard in advance that what are the possible defects which may arise, and when the rake comes to you, you should address these issues so that the maintenance time goes down. So basically, this is an effort to move towards automation. Now, and we have named such coaching depots as star coaching depots. So some coaching depots have been nominated. Say, for example, Guwahati has been nominated, Delhi has been nominated, Bombay has been nominated, where we are trying to bring in this technology. You have a machine vision inspection-based system, hot box detector, acoustic bearing detector, RFID readers and all. So this is the progression which is happening. And similar to the star coaching depots on the coaching side, in the freight side, we call it as smart yards. So when a train is entering into the yard for maintenance activity, the maintainer knows well in advance as to which wagon he has to attend and for what possible defects. So that two benefits, first of all, he gets a inspection of a component, inspection of the rig which has been done through this machine. So error of human inspection goes out. Secondly, he knows well in advance as to what is the item which he has to attend. So the time of maintenance also goes down. So we end coaching and I'll move to wagon. Before that, let me see if I have some questions. I'll try to address those questions. Is there any certification for passenger comfort and amenity levels too? There is no certification per se what Indian Railways has adopted as of now. Indian Railways does some quality audits on the rigs through external body. If you go onto the website, you'll also find that we have got some surveys done for the facilities which are provided in the trains. Like you would have heard that we have done surveys done for stations, and we say that Sikandrabad is the best station in A1 or Vijayawada is the best station in A2. Similar to that, we are getting some surveys done through external bodies for coaching trains also. But as such, no standard procedure has been laid down. Also, remember, Indian Railways is a very unique organization. In the sense, if any certification or any standard has to be laid down for the level of amenities, the standard is anyway there. It has been laid down by RDSO. But if the certification is also required to be done, RDSO is a body which can lay down the standards and can do self-certification also. So we have not gone for any external certification of the passenger amenities, which is still available in the coaches. Only thing what we have done is we are slowly starting the process that similar to the stations, we are doing the quality audits on these trains to see what is the cleanliness levels inside these trains, and we are ranking the trains based on that. Is there any particular plan by RB to upscale use of drones, Android drones for surveillance, reduce human intervention in detection? Yes, I give you an example of Ustad. Now, every department is doing something like that. Say, for example, the security department has started purchasing drones. If you enter a platform now, you will find that the drones are used if, say for example, Kumbh Mela is being organized and a large amount of work of dispersal of people needs to be done. So the security department has started using drones. We have started using these androids for quick gear examination. This is only 2 months, 3 months old process. MVIS was also only 3, 4 months old process. It may take some time to come in, but then railway is trying to keep in touch with the technology which is there in the country. Okay, so I'll come to wagon now, which is the next PPT. I'll stop sharing this and start that. So till now we have discussed what is a loco, we have discussed what is running, we have discussed what is coaching. We are now going to discuss what is freight. Now, freight is the earner, as you know, in Indian Railways. Indian Railways owns around 3 lakh wagons. There are different designs of wagons which are available on the Indian Railways. The wagons are predominantly, when they are designed on the design board, they are designed for a type of a commodity to be carried. So you will find that an initial design of a wagon has been made for some specific commodity which it wants to be with, for where we plan to use it for carriage. This is how the wagon design has gone up. So this is just a slide. You can see in detail as to later on as to what it is there. And these are the steps which have been taken to upgrade the design of the wagon. And there is an important parameter which is called payload to tear ratio. Now, payload is the capability, is the amount of load which is carried inside the wagon, and tear is the tear weight of the wagon. So, what happens if there is a wagon? It's a 100-ton wagon in which you are carrying 80 tons, and the tear weight, the empty weight of the wagon itself is 20 ton. So, the pay to tear ratio is 4. Now, logically also, as per common sense, we would always prefer that the pay tear ratio should be as high as possible. You don't, there is no fun in carrying dead weight. So what has happened over a period of time, Indian Railways has increased its pay tear ratio from 2.25 to 4.21. The benefit is, even by inducting lesser number of wagons, we have increased the haulage capability which is available in the country. These are different types of wagons which are available in Indian Railways. So we have open wagons, we have covered wagons, we have flat wagons, hopper wagons, freight vans, tank wagons, container wagons, special purpose wagons, and so on. Predominantly, you will find boxen wagon and BCN wagons, and you will find container wagons which are working across the country. Now, as you remember, we purchase wagons and we only maintain the wagons. There are 2, 3 principles in the freight stock which should be kept in mind. First thing is, you have to handle the wagon properly. Now, the wagon, when it goes to the private siding, if he does not handle the wagon properly, he damages the wagon more. So the downtime for maintenance increases. Second thing to be kept in mind is that whenever you're doing maintenance schedules, the wagon, as far as possible, should be offered for inspection when it is in empty condition. So in freight trains, the whole rake is offered for inspection, and it is desirable that the rake should be offered when it is in empty condition. Because if you offer it in loaded condition and a wagon is marked sick, or if a wagon is taken under repair, then transshipment would be involved. So you want to avoid that. As far as possible, the rake should be offered in empty condition. The third principle is that the rake is always offered for inspection in the direction of motion. So there are examination points where the train examination staff is located. And what I'm trying to say here is, assuming a train has to go from Baroda to Ahmedabad, and the examination point is at Anand, which is in the direction of motion, and the train has started from Baroda, so the next examination point is Anand, you will offer the train for examination at Anand. You will not take the train back from Baroda to, say, Surat for an examination and then push it to Ahmedabad. So train is always offered for inspection in the direction of motion. train, as far as possible, the train should be offered for examination in empty condition, and the wagon fleet should be handled properly so that the downtime for maintenance is reduced. Now, these are some numbers, and this is just to give you an idea as to what is there in the wagon. Now, this is a design of a boxen wagon. This wagon was designed initially for transportation of iron ore and coal. It's an open wagon. This is a bogie. This is called a Casnab bogie. It's a very simple design. It's a box. The length over couplers is 10 meters, approximately 10.7 meters. Why this length becomes important is because the length of the wagon decides how many wagons you can accommodate in a train. So in this case, because of this length is permitting me to accommodate 58 wagons. It also tells you what is the maximum axle load capability of this wagon. So this wagon can carry up to 20.32 tons. So if the gross load is 81.28 tons and there are 4 axles, if you divide it, you will get 20.32 tons. The payload of this wagon is 58.8 tons and the tear weight is 23.2 tons. So the ratio of payload to tear is 2.5. You want to improve this, and that is why you give variants to this design. So Boxen can be a parent design. You will find Boxen HL, Boxen HS. So these are all variants to this design where we are trying to either increase this payload to tear ratio capability, the maximum axle load taking capability, or trying to increase this speed potential of 75 oblique 80 kmph. The wagon is provided with a center buffer coupler. So this is some of the information which is coming from this design. And if you understand one Boxen, you will find that all others are in the Boxen design. All others are variants to this design. So, for example, if you see the next wagon, this is a Boxen HL. Now, in this Boxen HL, if you see the maximum axle load capability, that has been increased, or the maximum speed in empty condition has been considerably increased. So, we give variants to this design depending upon the traffic requirement. Now, this is what a Boxen wagon looks like. So, Boxen wagon has a body. It is the superstructure or the body of the wagon. This is the body of the wagon. This is a bogie. This is a Casnab bogie. It's a very flimsy bogie. Basic purpose is that you need a device to carry this load. These are the BPFP pipes which are provided for the air brake system. Now, this is the capability of the load and the tear which is there. This is a wagon number which has been provided on the coach, on the wagon body, the owning railway. The wagon stock is not owned by any specific depot. So what happens is, but notionally the wagons are allotted to a specific zone. And the history of the wagon is written on these end walls. So you will find that the history of the wagon is written here as to what is the date of commissioning of this wagon, when was the last POH done, or when was the last ROH done, or last major schedule was done. So whenever a freight train comes to a yard, the train examiner would be examining this whole rake. He would also be reading this history to find out if the wagon needs to be detached from the rake for any specific higher level maintenance. Similar to a Boxen wagon, this is a BCN wagon. This is what the covered wagon looks like. Now, this wagon was designed primarily for transportation of cement because you cannot carry cement in open wagons. Again, there are numbers. The length of this wagon is slightly more. So you will find we can accommodate only 40 wagons in the train length. The pay-tear ratio is slightly lower as compared to the Boxen wagon. And again, on BCN also, we have given variants to suit to commodity or to improve the speed potential or the load carrying capability of the wagon. Now, this is some similarity. This is, in this case, also the top portion is called the wagon body. Again, they are provided with Casnab bogies. So in all the designs of wagons, you have only Casnab bogie. This is a Casnab bogie. This is a Casnab bogie. This is the body. This is the body. And we provide something called hand wheels here. These are basically hand brakes. This is a mechanical brake. If a wagon has to be stabled in the yard, you're basically supposed to use this for stabling the wagons. Now, what happened? We said that we are removing our ICF coaches and pumping in LHB. So, rather than condemning the ICF coaches, we are finding alternate use for these coaches. So one alternate use is that these coaches have been converted into NMG wagons or new modified goods. What we have done is we have removed everything from the interiors and converted them into car carriers. So these rakes are now used for transportation of cars, and one rake can carry up to 125 cars. A specific design of wagon was developed in association with Maruti for carriage of cars, and that rake can carry up to 318 cars at a time of a specific design. But Indian Railways has been able to capture very only 4 to 5% of the automobile market which is there in the country. So that is why it was thought that rather than condemning these ICF coaches, we can, if residual life is left, we can always make alternate use and convert them into car carriers. You would have also seen photographs in the newspapers recently that we have loaded two-wheelers inside these coaches at south somewhere, and these rakes are being used for transportation of two-wheelers. So now this is a flat wagon initially designed for carriage of rails. Also, you would find this design for carriage of steel coils. An alternate use, a modification of this design was done, and this service was launched, which is called roll on roll off. This was tried in Konkan Railway and also somewhere in ECR. Has been not very successful. But what is done is that the trucks, the loaded trucks, directly come onto the wagon, and the benefit is that you have eliminated these large number of trucks from the road. The promise is that it will move faster. So basically, you are eliminating emissions from the roads. You are promising faster movement, and this experiment is called roll on roll off, and you are also promising point to point delivery. So a commodity can be loaded in a truck at one place. The truck can come onto the rail, get transported partially by the rail, get unloaded, and then deliver at the delivering point. Now, this is another design of a wagon called bottom discharge wagon. So, in this wagon, you will find that there are doors which are provided at the bottom of the wagon. So, these are doors. What happens, assuming if coal is loaded in this wagon, in some collieries, the pits, the conveyor belts are inside the pit. So, the wagon will come and stand on this track, and underneath the pit, in the pit, there would be a conveyor belt. These doors will open and the coal will drop on this conveyor belt and go to the thermal power plant. So this is a bottom discharge. A similar design of the wagon is there with side discharge. So this is side discharge wagon. You will find that the side doors happen. In this case, ballast is being laid to bobbin wagons for construction sites. Now this is a tank wagon. This wagon is used for transportation of petroleum products, and this tank wagon is provided with baffle plates. So what happens in this tank wagon? There are 4 compartments, and you will find that baffle plates are provided, and these baffle plates are primarily provided to restrict the hydraulic shock which comes if the wagon is loaded and the wagon is getting transported. So the force of the liquid which is inside this tank gets restricted by these baffle plates. The next kind of a wagon which we have is called a BVZI wagon or the brake wagon, in which the guard is traveling. The only difference in this case is that we have provided, in place of a Castnut bogie, we have provided an ICF bogie. And why? Because the Castnut bogie has not been designed for passenger comfort, but if a guard is traveling here, what we have tried to do is that so as to give him some comfort, we have provided an ICF bogie. Also, there was earlier no lighting arrangement in the BVZI wagon, because you cannot wire the whole train, and the guard used to sit in the rear in darkness. So some solar panels, we have started fitting solar panels on top of this BVZI wagon, so that at least the person who is sitting here gets one light, one fan, and one mobile charging point. So this has been named as Solar Comfort Guard Comfort Kits, and Aerof is doing this activity. Now the next kind of a wagon is a container wagon or a BLCA wagon. It is of two designs, and this is a very simple flimsy structure you will find on top of which the containers are loaded. So there is a BLCA and a BLCB design. What is primarily what you understand is that in the exteriors you put BLCA wagons where a center buffer coupler is provided, and in intermediate you will connect 3 BLCB wagons and make a consist of 5 wagons together. And in the BLC wagons, you provide something called a slackless drawbar. So this is not a center buffer coupler. This is a slackless drawbar, and the slackless drawbar gives you better strength. It does not permit the wagons to sway more. So this is a this is a BLC or a BLCB wagon which you would see for container movement. This is called double stack container in a non-electrified territory, especially on the Pipaplav line. We are using this because the container gives you volume. The container does not give you weight in large number of cases. So even if it is a 40-ton container, that for example, a container is there, the carrying capability of this wagon is 80 tons. There is no fun carrying a single stack container. So you have started using double stack container, and an experiment has been launched which is called as dwarf containers, so that under the electrified territory, so if there is a catenary on top and there is a rail at the bottom, this is the schedule of dimension which is available. As of now, if you use the existing containers, you are using only this space. So the container design has been changed slightly. We have made the containers to around 3/4 of the design, so that this maximum SOD can be used. We should be able to use this space also, and this is called dwarf containers. Central Railway has started this experiment, and you will find slowly that dwarf containers picks up. Now, this is a rake which was designed specifically for automobiles, and this was designed in association with Maruti, and it basically has two levels inside. So there are two levels inside this, and at the loading point, the cars will get loaded here, and the cars will get loaded here. Maruti, as of now, owns 14 rakes of this design and plans to purchase 4 more and run them on the Indian Railways. Now, wagon is a buy stock item. So the warranty of a wagon is 24 months from the date of commissioning. And the caudal life of wagon stock, even the caudal life of wagon stock is defined. So a box and wagon caudal life is 30 years, tank wagon caudal life is 40 years. And this is one notional average life after which you condemn the. There are different types of examinations which you do even in freight trains. So first is rolling in examination, which is similar to what is there in the coaching stock. There is some examination of the train at the originating station, which we'll see later. You can send wagons through passenger trains also, but some conditions needs to be met. Similar to the A, B, and IES schedules in the coaching stock, or D1, D2, SS1 schedules in the LHB stock, there is something called routine overhaul in case of wagons. So this is a periodicity at which you will take the wagon, detach the wagon from the rake, take it inside the ROH depot and do some maintenance. In the coaching stock, we call them as coaching depots. In case of wagons, we call them ROH depots. Now the train examiner. The train examiner is the person who is identifying the level of repairs which is happening in the wagon, and he can classify the repairs into these 3 categories: petty repairs, medium repairs, or special repairs. Now what happens in the yards? In the yards where the freight trains go for examination, one line is nominated. Generally, there are some lines which are nominated for inspection. There would be some lines for cross movement. When a rake comes on the inspection line and the TXR says that a specific wagon needs to be detached and placed on sick line for maintenance activity, what he's trying to say is that a separate line has been identified called a sick line, where some higher level of maintenance is required, and he'll keep the wagon on that line for maintenance. Next to the next to these freight yards, at major freight yards, you will find there are some ROH depots or routine overhauling depots also. If a wagon is falling due for ROH, or if the level of attention which needs to be given to the wagon is much higher than what it can be tackled on the sick line, then the wagon is detached and sent to the ROH depot. The categorization can also be in terms of category A, category B, and category C, depending upon the level of repairs which is required. And what I have written here interesting is that the wagons are also dispatched to the workshops. So there are 2 major schedules. One is the ROH, second is the POH. And so if it's a major yard, and the TXR has gone and examined the whole rake, and he finds that some wagon is due for ROH or some wagon is due for POH. He will detach that wagon from the rake and send that wagon to the ROH depot for ROH, and send that wagon to the workshop for POH. So the workshops are also located nearby. He will send that wagon to the closest workshop in which the POH is done. Rolling in is similar to what is there in the coaching stock. What is more important is yard maintenance, as to what is the maintenance which is done, what is the pattern of the examination which is done on originating trains. So there are three patterns of examinations which are done on an originating train, and that is called end-to-end, premium, and closed circuit. These are three examination patterns which happens on a freight train, and the location or the point at which these examinations are done are identified or selected in the zone by the PCME and the PCOM. So they'll say that, say for example, Baroda Yard is competent to do end-to-end examination. Anand Yard is competent to do a CC pattern examination. Now, when we notify an examination point, we build facilities to that level where where the train examiner can do that level of examination. So first of all, what are these examinations? Most basic examination is called end-to-end examination. So if a freight train has come into the yard, the train has been offered for examination, and I say that I have done an end-to-end examination. In end-to-end examination, what I promise is that my examination permits this train to go from one point to another point. So I have done an examination at point A. I will offer it up to one specific point B or point C. I have done examination at point A. The train comes to point B for loading, goes to point C for unloading, and then it needs to be offered for examination at point D. So I have given a BPC which is valid for one trip. This is called end-to-end examination. I promise that when I am giving you the BPC, the brake power which is available in the train is 90%. And the BPC would be white in color. So the BPCs are also of different colors. And the BPC of an end-to-end train examination is white in color. The brake power is 90%. Traffic will take this rake after examination, use it for loading and unloading, and again offer it for examination. The second pattern of examination is called premium examination. In this case, I will say that once I have done the examination, I have given the rate to traffic for use for the next 12 plus 3 days. So traffic can keep on using it for the next 12 plus 3 days. I have done examination at point A. Now, once I have done this examination, traffic can take it at point B, it can take it to point C, it can take it to point D. It can keep on doing this for the next 12 plus 3 days. Only condition is that at the end of this period, this rake has to be offered for examination again at an intensive examination point. So this is called premium rake examination. This examination gives more flexibility to the traffic to use the rake. So I do a premium examination at Baroda, he will take it, he will load it at Anand, take the train to Ahmedabad, unload it at Ahmedabad, again load it at Ahmedabad, take it to, say, Surat, or again back to Baroda. But he can keep on doing this for the next 12 plus 3 days. Only condition is at the end of this period, he needs to offer the rake again for examination. Here I promise him 95% originating brake power, and the color of the BPC is green. The third type of examination is called the CC rate examination, and this concept primarily came in for coal loading. So what used to happen was we used to load coal in the collieries, and the coal used to go from collieries to the thermal power plants. Again, the rake used to come back, we load, and again it used to go. So a thinking came that where the rakes are moving in a closed circuit, it is better that we go in for CC examination, and this is what the CC examination looks like. So we have done an examination at point A, and after that it keeps on moving in this circuit only. So the condition is that it should keep on moving in a circuit. And once we do this examination, we say that the rake is offered for the next 30 days for use of traffic department. So traffic does not need to bring it back before 30 days. The quality of the wagons which we are providing in formation of these rakes is considerably of better condition. So new wagons or off POH or off ROH wagons we would be putting in this rake, because once we have given this rake, we will not get it back before 30 days. Only condition is that it has to come back to me after, it has to move in a closed circuit. I am promising 100% brake power, and in this case, the color of the BPC is yellow. So this rake is also very much liked by traffic, because now he can use it for the next 30 days and he can forget to give it for examination again and again. So you would have heard names of black rockets. So these are some names which were given to such trains which were specifically being used for loading of coal. Now in all these three types of examinations, what are we doing? We are basically inspecting, repairing the brake gears, we are replacing brake blocks, we are seeing whether the CVC heights are okay or not, whether the brake cylinders are working fine or not. So the examination intensity will go up. So if it is a CC rake, we will be more, we will be spending more time to ensure that this is happening, because we have to promise 100% brake power. In case of an end-to-end rake, even the wagons would be slightly of a lower quality, and we would not be that much intensive, because we know that we have to give the examination only from one point to the other points. This is the color of the BPCs in all the three cases. And this is the information which comes in the BPC. More or less, it is similar. So you would find that the destination is valid from which place to which place, what is the train number, what is the load, what is the number of brake cylinders which are working, what is the brake power percentage, what is the list of wagons. So this is what a BPC looks like. This is the premium rake BPC. This is the CC rake BPC. More or less, the information is same in all the three BPCs. Now you assume a condition where a rake has to start from an unloading point and there is no train examiner who's. So one method is that I develop a flying squad. I send a tree XR from the closest examination point and tell him that, look, you take your staff, go to that point and examine the rake and give a BPC certificate. The second method is, which is broadly used, is called GDR check or guards driver report. So what happens when the rake is examined by the guard and the driver? So the guard and the driver will walk around the whole rake. They'll ensure that the CVC couplings are coupled, the old pipes, the brake continuity is there, all the angle cocks are open, the number of dummy cylinders are not exceeding the limits which are prescribed, all the doors of the wagons are closed. So they'll do this examination, and on their certificate, the rake is started. So this is called a GDR check. As soon as the rake is started, only condition is a rake can start on basis of GDR. In the direction of motion at the next examination point, the rake should be offered for examination to the qualified train examiner. This is the only condition. At a place, say for example, I have done unloading, and at that point no train examiners are available. So I will start the train with a GDR and bring it to the closest train examination point where qualified staff is available. The qualified staff will do this examination and then make the BPC valid either as end-to-end premium or CC. Now this is ROH, which we have already discussed, and these are some periodicities. This is, say for example, periodicity of the POH. So if a box and wagon is new, the first POH is done after 6 years, the subsequent POHs are done after 4.5 years. ROH again is done at a period of 18 months. So this is the time when we are taking the wagon inside the ROH depot and lifting the wagon, running out the bogies, doing that ultrasonic testing of axles, stripping the bogies completely and refitting fresh bogies. The target of wagon availability should be 96% of the holding. So if a zone is holding, say, 10,000 wagons, and on any day, not more than 400 wagons should be under repair, either in the sick lines, in the ROH depots, or in the workshops. There's an example just to tell you that how do we do categorization of the examination points. So say, for example, Central Railway, Bhusawal is a big yard, Ajni is a big yard. So they have declared that Bhusawal can do premium examination, it can do CC examination, it can do yard examination, sick line examination, it has an A-class ROH depot. Now these are alphabets. You will find that all the examination facilities, it may be a sick line, it may be an ROH depot, it may be a it may be an examination point or categorized. So we'll categorize them into A, B, C, D, E. A class would have the best of facilities. As the alphabet goes up, the level of facilities goes down. So all the examination points are categorized, and we know well in advance, say whether Baroda would be able to do a CC rate examination or not, whether Anand would be able to do a premium examination or not. The rake is taken, the specific rake, if a CC examination is required, the rake would not be offered at Baroda, it would be offered at Anand. Now, why I have shown you this wagon body is because the wagon body, when it comes to the workshops or it comes to the sick lines or to the arrows depots, faces two major problems and repairs are required. So the first problem is called bulging or body puncturing. What happens over the period of use, because of uneven loading or because of the components which are loaded inside the wagon, this body has a tendency to bulge or to puncture. Or you may find that these doors have got bent, the locks are not working. So if you go to any wagon workshop, you will find the major repair work which they are doing is body repairs. So they'll be cutting out one segment from here and patching up afresh. The second chronic problem which is there in the wagon which we face is called corrosion. Now this is open to atmosphere, and what happens because of the atmosphere, rainwater ingress, the type of the commodity which we are carrying, it leads to heavy corrosion in the wagon body. So this corrosion needs to be attended, and whenever the wagons come to the depots or to the POH workshops, the panels or the patches are cut out. Fresh panels and patches are inbuilt for tackling the corrosion repairs. So I'll show you some photographs like this is corrosion. These are some corrosions which are happening in the box and wagon. And this is corrosion. If you don't attend this end panel, if you see, this is the end panel. If you don't attend this end panel and repair to this panel, this corrosion in the longer run will eat this under frame, and there would be a case where the wagon is broken into two. So that is why corrosion becomes a very chronic problem. Like this is another photograph where corrosion is visible. So in a wagon body, primarily we are doing body panel patching up and the corrosion repairs. Anti-corrosive measures have been used. We have used anti-corrosive paints in the interiors. But what happens? The paints wear off very fast, and not much respite has been found by using anti-corrosive paints. Now this is what a cast-nub bogie looks like. So this is a very simple structure. Cast snub, as the name comes, it is something called cast snubber. So this cast snub bogie has got two frames. So these are two members. This is a cross member on which the center pivot pin is there. Two axles. So the wagon body will come on top of this. It will come through the center pivot to this side frame, to this secondary suspension, from the secondary suspension to the frame, and comes to the primary suspension, which in this case is a elastomeric pad. So this is a very simple design of the bogie, and some variants on this cast-nub bogie design has been used across the wagons, but predominantly the parent design is only the cast-nub design. And this is the set of the springs which is provided. These are nested springs, and set of 9 springs which are located inside underneath the wagon. So there is one of these springs inside this has called something called a friction snubber. Now if you see this photograph and try to make out, we have provided a snubber. So this is a metal wedge which is located on top of that spring, and this snubber rubs against a liner which is located on the wagon body. So this is primarily providing damping or any vibrations if it is happening inside the wagon body during motion. And that is how, because this is a snubber, cast steel snubber, that is why the name cast-nub bogie has come out. Now this is an angle cutout you will find that at the ends of the BP lines and the FP lines on both sides of the coaches or the wagons, we'll be providing these angle cutout cocks. So if this is one angle cutout cock, another angle cutout cock, one of a wagon body and a wagon body, these are connected with help of flexible hoses. And this handle of the angle cutout cock should be in line. If it is in line, the angle cutout cock is in open condition and the continuity of the BP pipeline across the length of the chain is maintained. So this is the thing which the driver is also seeing when he is doing that GDR check, or the TXR is seeing when he is doing the GDR check. And this is the thing which is getting confirmed on the BPC also, that when the brake pipe pressure is 5 kg in the locomotive and say 4.8 kgs in the guard van, we know that all the cutout cocks are open and the brake continuity is there in the system. Now the guard's brake van also has something called an emergency brake. It is a feature which is provided to the guard that in case of emergencies, he can also exhaust BP, the brake pipe pressure, from this emergency brake valve. Now, what happens is when he exhausts the brake pipe pressure from this emergency brake valve, the consumption of air in the BP line goes up. In the locomotive, there is something called an airflow indicator which is located. And an indication comes on the airflow indicator. The driver will come to know that the air consumption has increased in the BP line and he will stop the train. This is a similar concept in the coaching stock also. In the coaching trains also, there is a guard's emergency brake valve which is provided with the guard's van. And that is why sometimes you will find that if a train is moving from the platform and guard has also been able to apply brakes, basically what he has done is he has put this brake valve in emergency position, created an artificial leakage in the BP pipeline. The locomotive driver gets an indication that air consumption has gone up. So either an emergency brake application has happened or an alarm chain has pulled and he stops the train. Now there's an empty load device. This is a device which basically changes the mechanical leverage ratio of the brake blocks in the undergearing system. Just to keep in mind is that if the wagon is loaded, the device should be inclined towards the loaded position. If it is empty, it should be inclined towards the empty position. This is what a center buffer coupler looks like. We have already discussed the advantages of a center buffer coupler. So this is a center buffer coupler and it is having two knuckles. These are like palm ends, you can say, and these knuckles couple to each other. And if you see this is the knuckle. This knuckle is in open condition. This is the knuckle. So this knuckle is in open condition and this knuckle can be opened from outside with the help of this handle. So this is the operating handle. And when the train or the coach when the wagon or a coach needs to be connected to a locomotive, the pointsman will come and open this knuckle with the help of this handle. And the locomotive will push back and these two knuckles will couple with each other. Okay, and a quarter will drop to indicate that the coupling has happened. In case of screw coupling, what used to happen, there was a hook here and there is a hook here. So the pointsman had to stand here and physically put a coupling between these two hooks. And that is why it was more unsafe, because in this case, the pointsman is standing between the locomotive and the coach, or between the locomotive and the coach. So center buffer coupler, that is why I told you during the shunting process, if you remember, is much more safer as compared to the screw coupling. And this is the process how the coupling happens. This operating handle opens this knuckle, the knuckle of the locomotive or the knuckle of the another wagon comes, strikes it, and these knuckles get automatically coupled to each other. Now when you have to uncouple, you basically open this handle and then you can push the locomotive ahead. So it gets uncoupled. Now there is some wagon numbering scheme which has been adopted over Indian Railways. There is an 11-digit number which is added. There is a mechanism as to how you calculate something called a check digit. All these digits are identifying something. So the first two digits of this number indicate the type of wagon, next two digits will indicate owning railway, two digits indicate year of manufacture, and the four digits indicate individual wagon number. Just to ensure whether we have put all of them in the correct order, there is something called a check digit. When you study stores, you will understand something called PL number. So in a string of numbers, the last number is always the check digit to ensure the correctness of this string. And there's a mechanism as to how the check digit is calculated. So there's a worked example which you can have a look inside this as to how the check digit is arrived at. So this is a worked example as to how the check digit of 5 has been calculated. You get an idea how numbering is done. Now, all the workshops, all the ROH depots are coded with a 5-digit number. So for example, again in this codification, you will find the first two digits would indicate the zone. The next digit would indicate what is the type of the workshop. The next two digits would indicate the running number in that zone. Now the question arises, why do we codify all our workshops? Why do we codify all our ROH depots? Why do we go in for codification for so many things? This is done so that when we are doing financial activities, for example, if I have to compare, if I have to book an expenditure to Parel workshop, I'll book it to that number. If I have to book expenditure to Pratapnagar workshop, I'll book it to that number. And why I do this is just to compare the costs of maintenance which is happening in these two specific locations. Broadly, the cost should be the same, but if the costs become different, then you start thinking back and looking back as to what is required to be done. Why the cost at one place is more or the cost at another place is lower. So similar to the workshops, even the ROH depots are coded. Now this is an example. I told you that the examination repair facilities are also divided into categories. So category A would have the maximum facilities. Category E or category D would be having lower level of facilities. ROH depots are also categorized. So they are categorized as A category, B category, C category. Remember, A is always best, and as you move ahead, the level of facilities go down. Sick lines are also categorized, whether it is an A category sick line, B category sick line, or C category sick line. This categorization helps you to connect faster because you know that an A category sick line would have so many facilities, or a B category sick line would have so many facilities, and this is uniformly adopted across the country. So you understand that an A category sick line at Bhusawal or an A category sick line at Ahmedabad would have this level of facilities which is available. The ROH depots are also categorized like this, depending upon the level of attention they are paying. You have super depots, minor depots, major depots. Now, this is a slide just to tell you that what happens. The siding owners use large amount of components for loading and unloading of wagons. So railways is supposed to go and inspect the equipment which is available at the sidings for two-pronged purpose. If the wagons are getting damaged more, we penalize the siding owners. We tell them, look, you have damaged my wagon and we are going to penalize you this much. You're supposed to deposit this much amount of money to the railways. Secondly, as an education measure, we basically try to go and tell them, educate that if you install this kind of a facility, you will be able to unload faster or load faster, and in turn, you may end up damaging my wagon also lesser. We are moving towards stainless steel wagons because we have to eliminate corrosion. New designs of stainless steel wagons are launched. You would have heard something called long haul operations where we connect two trains together and run 102 wagon trains or 110 wagon trains. In the locomotive, if you remember, we had discussed something about distributed power control systems. So logically, the DPCS should be used, but DPCS is still under development. So we run these long haul trains with two drivers working independently to each other. This is the snapshot which just gives you to be kept in mind as that if the front train is empty, the rear train can be empty. Front train is loaded, rear train can be loaded. Front train is loaded, rear train can be empty. A circumstance should not happen where the front train is empty and the rear train is loaded, because then the loaded train is going to push the front train and develop chances of derailment. There's a device which has been used on the trains. The guard has basically three-pronged purpose. First of all, he confirms the completeness of the train. So on the guard's vehicle is generally the last vehicle, and there is an LB vehicle which is last vehicle board also which is provided there. So if a guard's van crosses the station, you know that the whole train has crossed the station or entered the station. Secondly, the guard is promising the continuity of the brake pipe pressure to the passenger, to the loco pilot. The guard is confirming that I have also got BP, so there is full brake power available in the train. And the third thing is that in case of emergency, if brake application is required from the rear, the guard is applying brakes also. So this is a device which eliminates the need of the guard and provides flexibility to confirm all these three aspects, and this has been used. We also use electronic in motion way bridges. This is nothing but a dharam kata on track. What happens when the when the siding has loaded something on the wagon, and what we do is we weigh the wagons on these electronic in motion way bridges first as a step to confirm as to what is the weight of the commodity which the siding has loaded. Say for example, siding has said that I have loaded 80 tons, so I'll do a super check just to confirm whether he has loaded 80 tons or he has loaded 85 tons. If he has loaded 85 tons, we have a mechanism of penalizing the siding owner and overcharge and charging him more. Second thing is more important is that, for example, if I am taking out a rake and the declared load of the rake is 4,700 tons, and I take it on an electronic in motion weigh bridge and I find that it is hauling 5,500 tons, then a scenario may occur where the train may stall on upgradients. You see, the locomotive is provided on top of the train. If it was a 4,700 tons, a declared capacity of 4,700 tons, I have provided an MU which is having, say, 5,000 horsepower capability. And with my terrain, I have declared that this MU can haul this 4,700 tons. But when I take it on an electronic in motion weigh bridge, I find that the weight is 5,500 tons. So what will happen on upgradients? A tendency may come where these locomotives may stall. Stalling is the process where the wheel is not rolling, but the wheel has started skidding. So on a curve, the locomotive is not able to execute the curve, and you will find that the train has come and stood as standstill on that upgradient, and the locomotive wheels, rather than rolling, have started skidding. So it stalls the process, and this problem becomes more prone, especially in cases of rains, because the adhesion factor has gone down and we have a failure. Now there is a direct failure. It may lead to a massive indirect failures. We lose large amount of punctuality, and so that is why these electronic in motion weigh bridges are used for these surprise checks. We're trying to improve the history of the RFI of the wagons, because we don't know what is the history of the wagons per se. We started providing something called RFID tags, parallelly RFID readers. This is a new design of a wagon which has been developed for the dedicated freight corridor. It's a 100-ton wagon, high strength, low alloy steel wagon. Please remember, DFC is only a carrier. The wagon stock would be owned by Indian Railways only. So Indian Railways would be doing maintenance activities on those wagons. At major junction points, this wagon stock would enter the DFC corridor, and at major junction points, it would come out from the DFC corridor back to the Indian Railways. So this is the latest wagon which has been designed. It's a boxed wagon which has been designed for the DFC with the very high pay to tear ratio and used high strength low alloy steel, so that the life of the wagon is more and the problem of corrosions does not occur early. So I end wagon here. I'll see if there are some questions. Okay. Tear weight includes fuel weight too. In the wagon, there is no fuel. It is a rolling stock. The fuel is there in the locomotive. When I am carrying the pay tear ratio, I am doing it for a wagon. I am not doing the pay tear ratio for the locomotive. Okay. When I come to the locomotive besides fuels also carries water. It also carries lubricants. In that case, I'll say what is the dry weight of the locomotive and the loaded weight of the locomotive. When the concept of pay tier comes, the concept of pay tier comes in freight stock or in wagons. Now, wagons do not carry fuel. There is no consumption of fuel. It is primarily a rolling stock. It is only getting pulled. So this question does not arise in that. Mechanical leverage ratio, exact numbers I don't remember. I can share it with you. I'll find it out. That in case of empty and loaded, what is the change in the mechanical leverage ratio? I'll find out and I'll let you. What is the meaning of loose shunting written on the tank wagons? What happens when a train is formed in the yards? Uh, Say for example, you have to form. You're forming a new train. Now, when you're forming a new train, you will pick up wagons from different lines, and you will put those wagons in one specific line. In some places, you do this process by pushing from the locomotives. In some places, you use something called a hump yard. So, for example, if you go to Lucknow, Lucknow is one place where we are using hump yard. The wagons are taken up to onto a hill, and at that place, once we have taken them on the hill by a locomotive, they are detached. The wagons roll down with the help of gravity, and the lines, individual lines, are set in the freight yard. So the wagons will come down and they will go and give a bump on a wagon which is standing there. So they bump heavily, they collide heavily. And this is called loose shunting. Shunting as a process should always be done slowly with the couplings connected. But in this case, where we are doing hump shunting, where we have simply left the wagon to roll and hump with gravity, or we are doing shunting also on level ground, where we have pushed the wagon and not connected the coupling, is called loose shunting. We don't want to do loose shunting in fuel tanks or in tank wagons, because assuming the wagon is loaded, and if you give a bump, the hydraulic load, the impact load because of the hydraulic oil which is available inside the wagon, would make the wagon unstable, and the wagon would have a tendency to jump out because of that impact. So that is why it is written there that no loose shunting should be done in tank wagons, because the hydraulic load becomes critical. Okay, so I will stop here and I will now come to the next presentation. I have one more left, which is workshops, and I think you all deserve a break. I also deserve a break. It is 10:05. I think my class is up to 11. So we'll start at 10:15. Okay, 10 minutes break for you and 10 minutes break for me. So we join at 10:15 for workshops.